Assalamu students. Today's topic is going to be about elastic collision in one dimension. First of all, students, consider two small non-rotating hard ball of masses m1 and m2. Let us consider this is m1, which is represented by a yellow color, and this is m2, which is represented by green color. Moving in such a way so that the center lies along the straight line with initial velocity v1 and v2 respectively. That means m1 has a velocity v1 and m2 has a velocity v2. Like this, v1 is velocity of m1 and v2 is the velocity of m2. Now m1 collides with m2 in a straight line, and this collision occurs, and after the collision, what will happen when they make a head-on collision with each other? The velocity becomes v1 dash and v2 dash respectively, as shown in figure. Now the velocity is changed, and the m1 is moving with velocity v1 dash now, and m2 is moving with velocity v2 dash, and they move away from each other. According to the law of conservation of linear momentum, that means which was equal to m1 v1 plus m2 v2 is equal to m1 v1 dash plus m2 v2 dash. That means the momentum before the collision must be equal to the momentum after collision, where m1 is the mass of the first object, v1 is the velocity of the object before the collision, m2 is the mass of the second object, and v2 was the velocity of the second object before the collision. And similarly, m1 was the mass of the first object, v1 dash is the velocity of the first object after the collision, whereas m2 was the mass of the second object, and v2 dash is the velocity of the second object after the collision. Rearranging them, we will get m1 v1 minus m1 v1 dash is equal to m2 v2 dash minus m2 v2. Now, why we are rearranging them? Because we want v1 of the first particle on one side and v2 velocity of the second particle on the other side. So in that manner, we can get m1 and m2 common in both the cases. So it can be written as m1 whole common v1 minus v1 dash is equal to m2 v2 dash minus v2. Let us call this equation number 1. As the collision is perfectly elastic, so the kinetic energy is also conserved. That means the energy before the collision should remain equal or same after the collision. So in that manner, half m1 v1 square plus half m2 v2 square, that means the energy before the collision, is equal to half m1 v1 dash square plus half m2 v2 dash square. That means total kinetic energy after the collision. Again, the same procedure. We will basically take the velocities of the first object on one side and the velocity of the second object towards the other side. After doing that, we'll get half m1 v1 square minus half m1 v1 dash square minus or equal to half m2 v2 dash square minus half m2 v2 square. So in this process, we have taken v1 on one side, the velocity of the uh, first particle before and after collision on one side, and the velocities of the second particle towards the right hand side. Now taking common, because m1 and half is in both the terms, so half m1 is common, v1 square minus v1 dash square is equal to half m2 common v2 dash square minus v2 square. So half will be cancelled. We can cancel half on both sides. This half and this half can be cancelled. So the next part can be written as m1, which is taken common, v1 square minus v1 dash square is equal to m2 v2 dash square minus v2 square. Let us call this equation 2. Now, if we want to cancel out these masses, let us divide equation 2 by equation 1 because we are concerned with the velocity at the moment. So, dividing equation 2, which is this equation, by equation 1. What do we get? We get m1 v1 square minus v1 dash square divided by m1 v1 minus v1 dash is equal to m2 v2 dash square minus v2 square divided by m2 v dash 2 minus v2. That means these are the moment of linear momentum. Sorry, this is the linear momentum for before and after collision of the second body and the first body, and these are the kinetic energy which we found out of the first and the second body. Now in this case, can we cancel this m out? So we are cancelling it out. M1 can be cancelled out with this m1, and m2 can be cancelled out with this m2. Now in this case, we are cancelling out the values, and what do we get? We get v1 square minus v1 dash square divided by v1 minus v1 dash is equal to v2 dash square minus v2 square divided by v2 dash minus v2. Now in this case there is a mathematical formula which is represented by a square minus b square. It is equal to a plus b into a minus b. If you multiply these two together, that means a multiplied by a, it will be a square, and a multiplied by b minus ab, and b multiplied by a, it will be plus ab. These two will cancel out and b square will be left behind. So it will be equal to a square minus b square. So in a similar method, there is square over here. So if we take this as a minus this as b, then the whole equation can be written as v1 minus v1 dash into v1 plus v1 dash. That means one time minus and one time is plus, divided by v1 minus v1 dash as it is. In a similar manner, we can apply the same method over here, that one time minus and one time plus. So v dash v2 dash minus v2 and v2 dash plus v2. So if we have the values similar to each other, so we can cancel these two values out because they are the same, and what is left behind is basically the values of the velocities. After cancelling these values, it will be v1 plus v1 dash is equal to v2 dash plus v2. This is equation number 3. Now we have to remember equation number 1, which is m1 v1 minus v1 dash is equal to m2 v2 dash minus v2. This will come later on, but we have to remember, and by rearranging this equation number 3, we can put different values of v2 dash and v1 dash in equation number 1. For that, we calculate the velocity of masses after the collision by solving equation 1, 2, and 3. The velocity of mass m1 can be calculated by putting the value of v2 dash. Now how can we get v2 dash? v2 dash is equal to v1 plus v1 dash minus v2 from the third equation. From the third equation we got this value. By rearranging the equation, we got v2 dash is equal to v1 plus v1 dash minus v2. Using equation 4 in equation 1, what was equation number 1? It was m1 into v1 minus v1 dash is equal to m2 v2 dash minus v2. Putting the value of v2 dash in this equation, what do we get? m1 v1 minus v1 dash is equal to m2 into v1 plus v1 dash minus v2. And v2 can be written as it is because we are putting in the value of v2 dash. Multiplying m2 in this whole bracket, what do we get? m1 v1 minus m1 v1 dash is equal to m2 v1 plus m2 v1 dash minus m2 v2 minus m2 v2. Now, as we can see over here, the things are getting complicated. So what do? We take v1 dash to one side of the equation, whereas taking all v2s and v1s on the other side of the equation to make it simpler. v1 m1 v1 plus m2 v2 plus m2 v2 minus m2 v1 is equal to m2 v1 dash plus m1 v1. Now in this equation, we have taken v1 dash on one side of the equation, whereas all the other components of v1 and v2 are taken towards the other side. Now in on the left hand side, there are two v1s. So this is v1 m1 and minus m2. So taking v1 common in these two, and v2 and v2 can also be taken as common. What do we get? m1 v1 minus m2 v1 plus m2 v2 plus m2 v2 is equal to m2 v1 dash plus m1 v1 dash. So taking common v1, we get m1 minus m2 common v1 plus m2 plus m2 common v2 is equal to m2 plus m1 v1 dash. Because we were finding out the velocity after the collision, that is why we are taking these components towards the other side. Here they are multiplying, on the other side they will divide. So m1 minus m2 into v1, which is this component, plus m2 plus m2 v2 divided by m2 plus m1 as a whole is taken division, which is equal to v1 dash. v1 dash is representing the velocity of the first particle or mass after the collision. Rearranging them, it will be m1 minus m2 v1 plus m2 m2, because they both are adding up to m2, and v2 is common still, divided by m2 plus m1. And this is the velocity of the first particle after the collision. And it can also be represented or written as m1 minus m2 into v1 divided by m2 plus m1 plus 2m2 v2 divided by m2 plus m1 is equal to v1 dash. That means these m1 and m2 can be written separately because it is the LCM. Now this was the velocity of the first particle. Now if we want to find out the velocity of the second particle after the collision, it will be v2 dash is equal to m1 minus m2 v1 divided by 2 m2 plus m1 plus 2 m2 into v2 divided by 2 m2 plus m1. Now how is it possible that we have already figured out the value of v1, we can find out the value of v2 as well, but we can repeat the whole process again by taking v1 from the third equation and by putting it this v1 dash in the first equation. What was the first equation? Using the equation number 5, in equation 1, which is m1 v1 minus v1 dash is equal to m2 v2 dash minus v2. Now in this case, we are putting the value of v1 dash to find out the velocity of the second particle. Now in this case, we are finding out the velocity of the second particle. Putting in the values, what do we get? m1 v1 minus v2 dash plus v2 minus v1 is equal to m2 v2 dash minus v2. Now again we are multiplying the m into the brackets m1 v1 minus m1 v2, which is over here, minus, because there's minus over here, minus m1 v2, and this minus multiply be with the other minus, it will be plus, so it will be m1 v1. And if we multiply this m12 into the brackets, we will get m2 v2 dash minus m2 v2. Again, the process has to be repeated. We'll take v2 dash to one side because this is the value which we want to find out, and taking all the other components towards the other side. So it will be m1 v1 minus m1 v2 plus m1 v1 plus m2 v2 is equal to m2 v2 dash plus m1 v2 dash. So here we have taken the V2 on one side and all the other components on the other side. Over here, V1 and V1 can be taken as common, and V2 and V2 again can be taken as common. So M1 V1 and M1 V1 are written side by side, so we have to take V1 common in that one. And M2 V2 plus M1 V2 again written side by side, so we have to take V2 common in that one. So equal to m2 plus m1 whole common v dash 2, that means v2 square v2 dash, that means the velocity of the second particle after collision is now prepared to be calculated. Taking this whole component and dividing onto the other side, what do we get? First we'll do a common part, m1 plus m1, it will be 2m1, we know that. Taking common v1 plus m2 minus m1 and v2 is taken common is equal to m2 plus m1 and v2 dash is taken common. Now we'll take and divide this m2 plus m1 on the other side. What do we get? m1 plus m1 v1 is taken common plus m2 minus m1 v2 is taken common divided by whole component m2 plus m1 is equal to v2 dash. Now, as we know that these two components are adding up, so we can write it down as 2m1 v1 plus 2 m2 minus m1 into v2 divided by m2 plus m1 is equal to v2 dash. Now we can separate these two values by because they both have the same LCM, so it can be written as 2m1 into V1 divided by 2 M2 plus M1 plus M2 minus M1 into V2 divided by M2 plus M1 is equal to V2 dash. Now in this way, we can calculate the velocity of the second particle or of the uh, mass M2 after the collision, just after having the values of m1, the mass of the first object, the velocity of the second first object, the mass of the second object, and the velocity of the second object, we can find out what velocity it would have gone after the collision. I hope you understand this lecture. Thank you very much for paying attention. Inshallah, we'll meet again. Allah Hafiz.